Welcome to our quick video introduction to Modulus. Modulus is one of those things that we learn early on into our AP Computer Science A careers, and something that initially seems very small, but hopefully by the end of today's video, you'll be able to see how far-reaching and important Modulus actually is for how small the operation actually looks. So let's jump right into it. Let's talk about our agenda and our goals for today's lesson and see where we're going to end up at the end of the video. So we're going to start out today with a quick warm-up, setting up our examples and seeing where we're leading to with Modulus. We're going to talk about the nitty-gritty of how we solve it. We're going to talk about its importance to computer science, practice a little bit as usual, talk about its relevance and its fit into our order of operations, and last but not least, wrap up and talk about and revisit our goals that we'll mention right now. What are our goals? So by the end of today's video, I'm hoping that I can get you all to be able to figure out and evaluate expressions using Modulus, just looking at a math problem and using Modulus. And then secondly, I would like you all to be able to also interpret Java code, because even though Modulus is far-reaching in computer science beyond our Java, we are learning Java in this course, so I want to make sure that you can interpret it in Java as well. So with that being said, let's jump right into the warm-up and see how you all do with this to set up our examples. So here's what I would like you all to do. I would like you all to take a look at the amount of candies that we have on the screen. I would like you to create as many groups of 3 as you can. So figure out how many groups of 3, all 3 candies in each group. How many can you create? Go ahead and pause the video, and then when you come back, I'll be able to explain and hopefully go over the answer with you. All right, hopefully you're able to take a look at this question and see how many groups of 3 you were able to create. So in the next slide here, I've figured out that we can create 3 groups of 3. So we have whole groups here, 1, 2, 3, 1, 2, 3, 1, 2, 3, and we were already able to create 3. And if you were to think about this in math terms a little bit, how many candies did we have total to start with? We had 9. So in this case, if we have 9 and we want to divide it into groups of 3, we had 3 groups left over. We had that division essentially there that we're dealing with. I want you to keep that in the back of your head as we talk about this next warm-up question. So similar thing here. I have adjusted the number of candies, but I want you to figure out how many groups of 3, whole groups of 3 can you create, and what happens after doing that? So that's an important question. So go ahead and pause the video, and we will regroup once you've done that. All right, so now we can hopefully see that we've started with a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, rather than the 9 that we started out with in the previous example. What does that mean? Well, that means that we still have our 3 groups of 3. We have, 3 happy classmates that have 3 candies in their group. But we have one last candy that doesn't belong to a group. Because if I add that candy into one of these 3 groups, we end up with 1 group of 4 and 2 other groups of 3. And that's not quite as fair as we would like it to be. So what is this one stray candy that we have here? What is the math term that we typically used in elementary school when we were learning division? If you remember a little bit back, this is what we call a remainder. This remainder, although in most cases when you're dealing with math problems nowadays, is not super relevant because we just divide and we get a decimal and we don't really care about the remainder. In this case, we're actually going to focus most of today's lesson on finding that remainder that we have there. What is the math term to find this remainder, and why is that relevant? Why do we care about learning about this? That's what I'm going to cover in the next couple of slides here. So what is the name of this calculation and this operation? This is what we call modulus or modulo. It is a useful operation that tells us if I divide this number by this number, what is the remainder that I get from that division? So we're not focusing on the actual division, we're focusing on how many of those stray pieces of candies do I have left over after doing that division. So the way that we sort of figure that out and the way that we create this operation is we use this percent symbol that we have in the middle. So for example, we start with the number, percent, and the thing that we're dividing by to get our remainder. So for example, here, if we go back to our previous example, we had 10 candies total. What we would do here is we'd put that 10 here where the number is. Next is, how many groups do we want to create from those candies? In this case, I would put 3 here. So I'd do 10 modulus 3. What is that going to give us? Well, it's not going to give us the division. It's not going to give us 3, right? Not 3 whole groups of those 3 candies. Instead, modulus focuses in on finding this remainder that we have there. So what it's actually going to give us is 1. Now, you might ask again, how is that relevant? But put a bookmark on that. We're going to come back to that in the next slide after this one. So let's go over a couple more examples here. So let's look at this first one that I have, which is 4 modulus 2, or 4 mod 2 if you were to do it a little bit simpler. 4 mod 2. What is that saying? Well, that's saying if I have 4 candies and I want to make groups of 2, how many do I have left over of making those groups of 2? Well, let's look at this left side over here. I've done that already for us. We have 4 candies and I make groups of 2. How many do I have left over that didn't belong to one of those whole groups of 2? I didn't have any. So in this case, I have a modulus of 0. My answer is 0 there. Now for this other question, we have 5 candies total, and I want to make groups of 3. How many do I have left over that don't fit into whole groups of 3? Well, in this case, I can make one whole group of 3, but I have left over 2 candies. They didn't fit into that group of 3, and I don't have enough to make another whole group of 3. So feel free to pause the video, do this sort of yourself, think about it in those terms there, but it's essentially focusing in on what is the remainder of making groups of the divisor. What do I have left over from doing that? So now that we've learned it, let's try and see why this is relevant. Why do we care? So why do we care? Well, we can use this in Java to figure out what we have as a remainder. And it looks exactly the same way that we've been doing just before as a divisor in normal math. So the way that we set this up is we can create 2 variables like we've done here. I do, int num equals 12, int divisor equals 5, and I can create it exactly the same way that I did with my math, but just printing it out right afterwards. In this case right here, a similar problem. If I have 12 candies and I want to make groups of 5, what do I have left over? Well, I'll have 2. And so this will actually just print out in our console the answer of 2. So in Java, it looks, a little bit different, but it's just because we have to create our variables in order to store those answers. All right. Now let's talk about the relevance to computer science in general. So why is modulus actually important? Well, first things first, you'll typically be using modulus to figure out what numbers are even and what numbers are odd. How do we use modulus? Well, if I do the modulus of 2, so if I figure out what is the remainder if I divide by 2, if there's nothing remaining after I divide by 2, then I can deduce that that number is even. So if you look at this first example right here, 20 mod 2, 20 is an even number. If I mod by 2, I have nothing left over, so I know for sure that this is an even number. The other way around also works too, right? So if I have 35 mod 2, that is going to be an odd number, which means that I'm going to have 1 left over every single time. So that means that if I have that 1 left over, I can make sure and I know that that number is going to be odd. So if I wanted to, I could replace this 20 and this 35 with a variable that you can use the user input, whatever it is, that wherever you're getting that number from. But I know for sure, if I mod it by 2, if it gives me 0, then it's even. If I mod it by 2 and it gives me 1, then I know it's odd. Always going to work. What's another case? Well, another case that this is going to be useful, and I'm going to promise you right now this is not going to make a whole lot of sense because we haven't learned about conditionals just yet, but I'll talk about that in a moment. But modulus also helps us figure out if we need to, do something every 6th time. For example, if I press this button and, if I press it and every 4th time I want it to greet me with hello. Well, in this case, you can use modulus for that same reason. So if I want my code to execute every 6th time that it's called, well, in this case, I can do mod 6. And if mod 6 is 0, then, I know it's my turn to run it. So this is something that's a little bit more complex. We haven't learned about if statements and conditionals just yet, but just know in the back of your head, modulus is going to be relevant for us to know, if I want to do something a certain number of times, I can use modulus for that. All right, so now that we've learned that, let's take a look at some more practice examples, both, using normal math notation, and also a little bit later on we'll talk about notation in Java, because I want to give you enough practice that you're confident leaving this class. So let's do our first practice problem, and feel free to pause once I explain and I give you the sort of math breakdown of this. I want to do 10 mod 3. Go ahead and pause the video, and when you come back, we'll go over what the answer is here. All right, so if I do 10 mod 3, what is this saying? It's saying if I make groups of 3 out of 10, what is left over from that grouping? So if I do that, then I have one group of 3, a second group of 3, a third group of 3. What do I have remaining? I have remaining 1, which if you think back, this was actually our warm-up question, so you're just looking at it as, separated from the candies for now. So this is essentially the same warm-up question that we first posed at the beginning. All right, let's look at a second example here. So now we're actually using Java. Now let's take a look here. Int x equals 3. So I'm creating a variable called x, and I'm putting, 13 in there. System.out.print x mod 8. Go ahead and pause that and tell me what is x mod 8. All right, so if we're doing x mod 8, what it's essentially saying, and what we can plug and play with, is we can say, all right, x is 13. We already set that up before. So it's essentially asking us, what is 13 mod 8? Well, what is 13 mod 8? In this case, if I make one grouping of 8, which is the only thing that's allowed if I have 13 total, then I have 5 candies left over from that, and that means that 5 is my answer. So this is going to print out to console the number 5. All right, let's try one last example here, a little bit more complex in Java, but go ahead and pause the video and try this one out. All right, so a little bit more complex. Now we have 2 variables that we're trying to do the modulus from in this case. So if I have my x equals 25, my y equals 5, and I do x mod y. So if I do this, it's essentially asking us, what is 25 mod 5? So if I have 25 candies and I want to make groupings of 5, what do I have left over from doing those groupings? Well, in this case, 25, is divisible by 5. So in this case, we have nothing left over, and we know that 25 is divisible by 5. So this is again, very small operation that a lot of people overlook, but it is very powerful for a lot of different reasons. It gives us some easy ways for us to figure out remainders that wouldn't otherwise be possible with more complex code. All right, now let's talk about how does this fit into our order of operations? Because typically, especially on the AP exam, we're almost never going to see modulus just by itself. Instead, it's going to be mixed in with all of our other normal operations that we've seen in math and in Java. So in math and Java, we use PEMDAS to figure out our order of operations. If you need a reminder of what PEMDAS is, that graphic at the bottom there tells us a little bit what it does for us. So PEMDAS essentially says our order that we need to solve our calculations is parentheses, exponents, multiplication, division, those sort of are at the same level, and then addition, subtraction, those are also at the same level. Well, where does modulus fit in? Well, because modulus is sort of an offshoot of multiplication, division, well, more specifically division, it actually slides right into that same level of operation. So if you are looking at a complex math problem, take a look and see where are multiplication, where is our division, where are our modulus. If there are multiple of those at one time, then you just go left to right after you've done your parentheses and exponents. So it slides in at the exact same level as our multiplication and division, which make things a little bit easier. It'd be hard if we added another level in there. All right, so now let's see. We've had a pretty powerful video here to figure out What is modulus? How is it useful? So let's revisit our objectives and make sure that you're walking away with the important things from this video. So first, please make sure that you're able to evaluate some of these expressions using modulus. So without looking at any Java, just look at, if I do this, mod this, what is going to be my answer from that? Second, what does it look like if I implement it using Java code? Creating some variables here, printing it out, doing our modulus. Does it make sense? Do those things sort of go hand in hand with what I think it's gonna evaluate to be? That's what I want you to walk away with primarily from this video. Last but not least, we did learn also how it is used in computer science, whether it's to figure out if a number is even, or also to figure out, how many, what the nth time is, and figure out how it's relevant to us there. And last but not least, how it falls into our order of operations, which is going to be very important, especially for our multiple choice questions on the APCSA exam in May. So I hope this video was useful. As usual, please let me know if you have any questions, and I will see you all in the next video.